Welcome to ICP Girl Channel. Happy Friday, and I hope you are all well. There is something to celebrate together. Internet computer reached 1 billion blocks. The genesis of the Internet computer happened in May 2021 with the vision of being a world computer that removes the traditional limitations of smart contracts using advanced new cryptography and distributed protocols. This needed a completely new architecture of a blockchain which would allow for scalability and speed, for which we need to look at the very basic element, i.e. the block. It's important to understand how the metric of number of blocks means something really revolutionary for Web3 and why 1 billion blocks is a big deal. What is a block? Blocks are the fundamental units of any blockchain. They are like records that store valid transactions like a page of a record book and are hashed and encrypted. A block is very secure and is impossible to hack. A block contains the recent data, and every time the block is completed, it becomes a part of the past and makes room for a new block on the blockchain. The completed block is a permanent record of prior transactions, and new ones are recorded in the current one. As a result, the entire system enters into a loop that permanently saves all data. So the number of blocks need to keep growing to sustain higher throughput on the blockchain. Let's look at an industry context here before getting into further details. It's quite evident that the way the traditional blockchains have been architectured around proof-of-work mining protocols, it's not easy for them to scale up the number of blocks. It's quite evident that the way the traditional blockchains have been architectured around proof-of-work mining protocols, it's not easy for them to scale up the number of blocks. Scalability issues have long stood in the way of blockchains' widespread adoption, preventing it from providing optimal solutions to businesses and industries. Low transaction speeds, high transaction costs, and simply not enough computing power has prevented true mass-level innovation to happen on the blockchain. The Dfinity Foundation recognized that a blockchain network needs to run at internet scale and web speed to take this revolutionary technology mainstream, which is why Dfinity developed novel cryptography and computer science to build and launch the Internet computer. As a result, ICP was designed to scale, meaning that the network can adopt more machines, more subnets, and grow the total amount of blocks. The Internet computer's partitioning into subnet blockchains is what allows the network to infinitely scale. Each subnet is like a blockchain with its own blocks, which is capable of processing update and query calls independently from other subnets. Running a mainstream social media, gaming, or video streaming application on the blockchain needs to be able to hold a lot of data on the chain, which mean many more blocks. Today ICP has a bustling ecosystem of full-stack D apps running on its blockchain. They are 100% on-chain, run on web speed, and are not expensive to function. Since a principal is a text representation of a public key of an asymmetric cryptographic key pair, each principal has an associated private key. Both keys are stored as an object referred to as an identity. If the benefits of blockchain have to be adopted by mainstream users and industries, it has to be possible to scale up entire functioning dApps, front-end and back-end, on the blockchain, and not just the smart contracts, like in Ethereum. You could install multiple identities on your machine, with each identity having a name. I will leave an article written by Shruti Satwala in the description for further reading. Thank you for watching and see you next time.